Okay, so let's talk about carbocation stability, right? A carbocation is when you have a carbon atom that has a plus charge, okay? So if I draw a plus, it means that that carbon has a plus charge, right? So another way to draw this, what we have to remember is when we have a carbocation, we have a carbon that is only forming 3 bonds. Okay, so if you remember our formal charge, carbon wants to make 4 bonds, but it only has 3, right? So it wants 4 valence electrons, but it only has 3, right? Therefore, it has a +1 charge. So this carbon has a +1. All of the other carbons don't have charges. They have full octets and are all making 4 bonds. Okay, so we have to make sure we're aware, right? We don't have to explicitly draw the hydrogens. If I put a plus near a carbon, right, we really have to recognize that that carbocation is only forming 3 bonds. All right, so what we want to remember about carbocation stability is a tertiary carbon is more stable than a secondary carbocation, which is more stable than a primary carbocation. Okay, so if I draw this carbon in blue, and that is attached to 3 other carbons, right? So that can be methyl groups, right? That could be, ethyl groups, whatever. 3 carbons, that's a tertiary carbocation. That's more stable than a secondary carbocation. So here we have a carbon that would be connected to 2 other carbons and then 1 hydrogen. So this is a secondary carbocation. We need to draw the plus, and that's more stable than a primary carbocation. So that is a carbon that's connected to 2 hydrogens. And then 1 other carbon. Okay, and that has a plus here. All right, and right, those are always going to be more stable than a kind of methyl carbocation that's attached to 3 H's, right? But we're really not going to encounter those much. So we see tertiary is more stable than secondary, which is more stable than primary. All right. So let's look at these carbocations in a little more detail, right? So if we look at this center carbon here, it forms 3 bonds, right? So that carbon is sp2 hybridized. So what that means is that carbon has an empty p orbital. So when we have a carbocation means we have an empty p orbital, right? So all of these examples have an empty p orbital. Carbocations are highly reactive. They're not following the octet rule, and all of these carbons are sp2 hybridized. All right. So the question is really why, right? Why is a tertiary carbocation more stable than a secondary, so forth and so on? And there's a one-word answer, and that answer is hyperconjugation. Hyperconjugation. All right. So let's take a look at what hyperconjugation is. All right. So hyperconjugation is the interaction of the electrons in a sigma bond, so usually a CH or a CC, with an adjacent empty p orbital to give an extended molecular orbital that increases the stability of the system. Okay, so here is our carbocation. There's our carbon with our plus. We see that this is attached to 1 carbon, another carbon, and an H. What type of carbocation am I drawing here? Right, this is a secondary carbocation. And what I've done here is I've really drawn in, right, there's our empty p orbital. So here's our empty p orbital. So hyperconjugation is when you have an adjacent sigma bond. So here's our sigma bond between the carbon and the hydrogen. Here's another one. This interaction here, when these align perfectly with that empty orbital, this plus charge gets to feel a little bit of these electrons. It's like a support system, right? Now, hydrogens, because these are a 1s orbital, they can't donate any electron density. They don't donate any electron density. So the more substituted the carbon, right, the more that carbocation feels like it has electrons around it to support it, it makes the whole system more stable. So if we had a tertiary carbocation here instead, we'd have 3 sigma bonds supporting the empty p orbital, right? 3 would be better than 2. Okay, 2 is better than 1. So it's these interactions here, right? And only one bond can be parallel at a time because the adjacent carbons are sp3 hybridized. All right, so that's what hyperconjugation is. And the analogy I like to say is, pretend you are a carbocation and you have 3 roommates, okay? 3 roommates. So you've got a carbon roommate, another carbon roommate, and a hydrogen roommate. And let's say something bad happens to you. Maybe you break up with your boyfriend or your girlfriend, or you know, you don't do well on a biology test, something like that, right? The carbon roommates are supportive to you. They make you feel better. Hey, it's okay, you'll do great on the next biology test. Or, the person you were dating, they weren't cool anyway, right? They're supporting you to make you feel better. The hydrogen atom is the roommate who just doesn't really care. They go about their business. They don't offer you any support, right? So if you live with 3 other people and they're all supportive, that's better than living with just 2 people that are supportive. And that's basically kind of an example of what hyperconjugation is, all right? So again, we really need to know tertiary is more stable than secondary, which is more stable than primary because of hyperconjugation.